computing become less noticeable, you can call it ubiquitous computing. And if you design it to be wearable, you can call them wearable computers, including those that are designed onto our clothing, the glasses, etc. can be considered as such pervasive computings. When you consider to develop mobile applications, you will consider some of these situations. The first is definitely mobility. We have to consider whether the mobile applications are suitable to be designed under a case where we can actually use it all over the place. So mobility is a very important aspect for us to consider. It will be pointless if we design an application that is only useful at a single location. We also look into the business context to ensure that there's such rationale to implement such a mobile solution, and there will be actually people interested to use such a solution. We'll have to look into the mobile application architectures and trying to check the pros and cons of each other to solve the problem. So we have to understand what kind of architectures that we could be selecting and using. We'll actually have to look into the mobile infrastructure as well, knowing what kind of devices are supported and how we can connect to the network using these devices. This helps us to define the target range of users that we could be actually looking at. We'll definitely have to work on the client user interface, which is different compared to our desktop applications, and we have to design the application as well that is often optimized for better performance in mobile devices. We often need to deal with the data transfer between server and client. We often will consider mobilizing existing application architectures that are already existing on other platforms. We have to worry about security, including authentication, encryption, etc. And we also need a normal development management, just like how we have in normal desktop applications design. We do have proper mobile application development management as well, where we need to have proper phase in design, development, testing, implementation, and etc. For mobile application development, it is changing from time to time, and different work groups had previously worked together to help us shape such environment for these mobile technologies. Two very important ones to highlight is WAP and OHA. WAP, or Wireless Application Protocol, is a lightweight protocol designed to provide internet communications on resource-constrained devices. These resource-constrained devices are mobile devices because they have less resources. As we discussed earlier, this is due to the size of the devices. WAP is an open, global specification that is allowed to be used by anyone. This is a standard created by the various companies that are interested to ensure that cellular phones can access internet with an easy and convenient method and manner without worrying what are the manufacturers, what are the specifications of the device, and etc. WAP is created to ensure that easy and fast delivery of relevant information and services to the mobile users can happen. And it is designed to ensure that all sorts of devices from low-end to high-end devices can be using WAP. It is also designed to be used on various types of wireless networks, and you can see a large range of wireless network here, including CDMA, GSM, GPRS, and etc. It is also designed to work with the various operating systems such as Palm OS, Windows CE, and etc. WAP is designed to provide certain benefits to different parties, including to the mobile carriers. So if certain carriers are using WAP, then they will be able to generate revenue because they can easily get customers and users that are using such WAP services. They offer wide broad market for developers because developers can start to develop applications without considering the specific device they are targeting at, because if a device uses WAP, it will generally be compatible. WAP will increase sales for device infrastructure and gateway manufacturers that uses WAP for their devices. And WAP means freedom to the end users, that the users are not actually restricted by what sort of device they would buy and what sort of outcome they would get, as devices are generally expected to use this same open standard. And the devices can also have a WAP-based microbrowser to access the internet to view web pages and etc., which is an important value-added service. A WAP forum is set up to actually discuss and to create such a WAP protocol, and these are some of the objectives. As you can see, the major part of this WAP forum is to create a global protocol that works with different technologies. The idea is to ensure that everyone could use this same protocol and there is no differences regardless of the device type that you are using. So they submit specification for adoption and enables applications to scale across this wide variety of devices. WAP is barrier independence, so regardless of what network that you are using, you should be able to get the information that you need when you go online and also to download applications that you need. WAP is also device independent, so you can use it for all sorts of devices regardless of the types of devices. It can be very powerful devices, it can also be very low-level devices. WAP also provides a micro browser that allows you to browse the net, which is using very minimal RAM, ROM, display, CPU, and keys. Of course, back then, most of the connection are very slow, and GPRS is the main way of connecting to a network when WAP is made available. And to make sure that browsing experience will be a bit smoother, a wireless markup language or WML is created as a simplified markup language to show contents to the users. You can design it directly as WMLs, or you can use filters or proxies to actually convert existing HTML pages into WML before sending them to your device. You can also download the applications from WTA servers via this method. Things changed in 2007 when Apple launches an evolutionary mobile device, the iPhone. This is the start of the smartphone era. The use of touchscreen with multi-touch capability is something extremely new. Previously, there are PDAs and etc. where you can use a stylus to control the touch screens and etc. But no one had ever seen something like this, a multi-touch device. This is very different, and iPhone does not want to join an open community like WAP. Apple develops iOS specifically for iPhone, and it is a very different closed system compared to previous open standards. In order to tackle such situations, the open community started Open Handset Alliance to create a newer standard and a newer mechanism that is at least comparable to the idea of iPhone over WAP. This is formed in November 2007 with a collection of more than 50 technology companies joining hands to create a new open standard. They're hardware manufacturers, mobile carriers, and software developers. They wanted to try to have a commitment to openness, shared vision for the future, and concrete plans to make the vision a reality. They want to accelerate innovation in mobile and offer consumers a richer, less expensive, and better mobile experience. They want to build a better phone for consumers, and they want innovation to be in the open. And they did make this a reality, and that is what we have today, Android. The manufacturers that are involved includes those that are designing Android handsets, semiconductor companies, and also content providers, mobile operators. So we know that OHA technically gave us Android. And Android is actually born from this group rather than Google itself. So that's a short history of Android in terms of how they got started. And the first Android SDK is made available in November 2007, shortly after iPhone made their debut. Android version progressed very quickly ever since it was introduced, with 2 major version updates released every year, at least. Android uses an idea that is having a virtual machine similar to JVM, but the Dalvik virtual machine is said to be more compact and efficient. Newer versions now replace Dalvik VM with ART, ahead of time compilation. They uses core libraries from Java libraries and therefore allowing developers to develop Android applications using Java. What can Android do? They allow storage of databases or files that were not allowed in some older operating systems such as Symbian OS, where storage of databases and files are restricted by the operating systems. They allow networking, that Android devices are internet ready and you can deal with the raw Java sockets, and you can also use a built-in WebKit based web browser, the Safari widget, to be used in the applications directly. They can deal with multimedia, playback and recording. They can deal with GPS to get location of the users, and they can also try to manipulate phone services, initialing calls, sending and receiving SMS messages. The general concept of Android application is to write the applications in Java. It will be compiled into bytecodes, and these bytecodes will be compiled together with the Android manifest and resources into a APK file, which is the installer for Android applications. There are 4 major components in Android. That includes activities for us to design UI. This will be an important class that we will use in practicals in the coming chapters. You also have services to run background work that doesn't involve UI. We have broadcast receivers to send information, and announcements. And we have content providers to provide app data to other applications. The activity allows us to design user interfaces for our applications. Typically, an application can have one or more activities, with each activity being aimed to design a certain UI for interaction with the user. From the moment the activity appears on your screen until it is hidden, it goes through a number of stages, and this is the life cycle of your activity. This is an example of how the activity looks like. We can also activate different components. The content providers are activated by a content resolver, while activities, services, and broadcast receivers are activated by intents. Intents are asynchronous messages. You can try to send this message to activate an activity or run a service. The Android manifest that is included in the APK is an important file that declares all the app's components, the libraries that the app needs to be linked against, as well as identifying the permissions that the apps are expected to ask for permission to be granted. The Android manifest.xml roughly looks like that. You can write and develop different Android applications for different purposes, and these are some popular examples. So how to start? We need to actually know what is the target platform that we are aiming to develop our applications due to the differences of the platforms. So you have to have an idea whether to develop for Android, iOS, Windows Mobile, or all of them. You can select the different tools that allows you to get your job done. For example, in Android, you have various types of IDEs that allows you to write Android applications. For Android development, Android Studio that is released in December 2014, some years after Android was made available, is the default options of developing Android applications today. You can also use other Java IDE and adding them up with Android SDKs, including Eclipse, which is a very popular choice back then. The life cycle of the mobile application were different compared to the desktop application. The applications are not started using a main function as the starting point of the application. Each activity will be activated, and there will be one that will be the starting point. And once the activity is activated, there's a life cycle of the activity. The programmer can control what happens during the different stages of the life cycle by overriding the corresponding methods. The predefined abstract functions are available, and you can try to override them accordingly. In Android, the lifecycle of the activity contains 7 stages, and these stages can all be overridden. And this is roughly how the stages move from one stage to another until the last destroy state. That is for our course today, and we hope that you enjoy the course, and please stay tuned for more practical classes in the upcoming chapters.